And for our GCE candidates, the good news is here. This video will enable you to solve all the problems that you're encountering in physics. This video is filled with all the information required to write this year GCE Physics. And mind you, do not ever skip this video, because this video will serve as a password that will enable you to do your physics very, very well and come up with an excellent result. Do not ever skip this video. Get your pen and paper ready, because this video is the solution that we've been looking for. My name is Nnajofo Stanley Ebuka. I will be taking us on physics today. Please, I want us to pay attention, as this lesson today will help us to understand so many hidden facts in physics. If today is your first time of joining us, do well to hit the like button and also the subscription button, so I can be able to get notification anytime we post another video. Okay, so I want us to pay attention. I will solve each of the questions step by step. So I want you to pay attention, give me your maximum cooperation, and do well and to drop question in the comment section. I will answer the questions accordingly. So let's start. I will start with question number 1. It says, let me repeat the question again. A stone of mass 200 grams attached to a string is made to revolve in a horizontal circle of radius 1.5 meter at a steady speed of 5 meters per second. Full stop. Calculate the tension in the string at the bottom of the circle. Let's look at the solution to question number 1. To do physics is all about visualizing a given question. So first of all, visualize the question and see what it means in real life. That's the problem students have in physics. They fail to visualize a given equation, a given problem. So let us visualize this question number 1 and see what it's all about. So there is solution. Okay, so a stone of mass 200 grams attached to a string. So I have a stone. Okay, I have this is a string, and I have a stone. This is a string, and I have a stone. Okay, we do this when we are small. Normally do it when we are small. So a stone of mass 200 grams attached to a string. So I've visualized the first particular statement. It's meant to resolve in a horizontal circle. So we want to turn this in a horizontal circle. Recall that this is vertical, while this is horizontal. So I want to rotate this particular stone in a string in a horizontal circle. So I form a circle with my stone. And this circle I formed here with the stone, they say that the radius of the stone, the radius of the circle is 1.5 meters. Okay, remember this is a string. I'm winding it to form a circle. So the circle I formed here, this is the radius of the circle, 1.5 meters. Okay. Now they say we should calculate the tension in the string at the bottom of the circle. Now watch what is happening here. As I'm winding the string with the stone, I form the circle, and this is a circle formed here. This circle formed here has a radius of what? 1.5 meters. So let's visualize and see what happens now. This is my string, and this is my stone. As I'm winding this string with the stone, I form this particular circle that has this radius of 1.5 meters. Okay. Now they want to calculate the tension in the string at the bottom of the circle. So this is the bottom of the circle, and this is the top of the circle. We don't care what is happening at the top of the circle, because the physics of what is happening at the circle will be quite different with the physics that is happening at the bottom of the circle. So they want us to focus on what happens at the bottom of the circle. So at the bottom of the circle, let's see what happens at the bottom of the circle. Now, at the bottom of the circle here, there is a force, we'll call it weight, that acts downward on the stone. The weight is acting downward on the stone. The weight is giving us what? Mg. Now on this string here, there is a tension that is trying to maintain the string with a stone in a centripetal path. they are causing it to undergo centripetal motion. This circular motion, that is the force that's causing it to undergo this centripetal motion rather. I want to believe that we understand this particular visualization. If you don't understand, drop your question in the comment section. Okay, let's proceed to finish the whole thing up. Now, look at the system we have here. The system we have here is a system where two forces are acting on this stone that is standing on a string. The two forces are tension on the string and the weight of the stone. So, according to Newton's second law of motion, the resultant force that acts here will be equal to mass times what? Acceleration. Now, the resultant force that acts in there is tension minus what? The weight of the stone acting downward, and formula for weight is what? Mg. Mass times acceleration due to gravity. It must be equal to mass times what? Acceleration. So if this is true, we now know that from our elementary physics, the formula for calculating this acceleration here, known as the centripetal acceleration of an object that is undergoing a circular motion, is given as A equal to V squared all over R, where V is the constant speed the object, or in this case the stone, is using to move in a circular path, and R is the radius of the circle formed. And from the question, V is given as 5 meters per second. While the radius of the circle formed, R, is equal to 1.5 meters. So we are good to go. Here, the mass is equal to 200 grams. Now recall that the unit of measuring mass is kilogram. That is the SI unit for measuring mass. It's not gram. So we need to convert this gram to kilogram. So how do you convert gram to kilogram? You divide by 1000. It's actually very simple. Look at the conversion here. You say that 1 kilogram is equal to 1000 grams. So X kilogram will be equal to 200 grams. Gram will cancel gram here. If you cross multiply, you'll now see that 200 kg all over 100 will be equal to X. So divide both sides. This 200 gram now will be equal to 0 will cancel 0, this will cancel, will be equal to 0.2 what? 0.2 kilogram. So the essence of this conversion is for us to have the idea. You don't need to memorize anything in sciences, you just need to know it. Just know it, you are good to go. No need for memorizing. So 1 kilogram is equal to 1000 gram. To convert 200 gram to kilogram, in our case, since 1 kilogram is equal to 1000 gram, we don't know how many kilogram will be equal to 200 gram. You put it X. If you cross multiply, this X will times this 1000, and 200 will times what? This kg. After you see that gram will cancel gram here. So after your cross multiplication, you find out that your 200 gram will be equal to what? 0.2 kilogram. Okay, so in this case, our mass now will be equal to 0.2 kilograms. Okay, we have got the necessary parameters needed. Our V, the steady speed, is 5 meters per second. Our R, the radius of the circle formed, is 1.2 meters. The mass of the stone that is undergoing the circular motion is 0.2 kilogram. G, which is acceleration due to gravity. I would like to explain what G actually means in the next video. It's a special concept that many students don't understand. I will explain the concept of G in the next video. So in this case, I will use G as 10 meters per second squared. So having gotten all these parameters, you see that it's very easy for you now to get your tension that you're looking for in this question. Okay, you know that my tension minus mg, that is the weight of the stone acting downward, is equal to mass times acceleration. Remember where we get this particular expression from Newton's second law of motion, where he defined what force is all about. Recall what I told you? We don't have anything like definition of a single force. What we define is resultant force, the sum total of force acting on a system. That is the definition that we have. We don't have a definition for defining one single force. No, we don't have it. We don't have a formula that we can use and show that. But we can show the sum total of force acting on the system. And the sum total of the force acting on the system or on the body is mass of the body times the acceleration produced. Okay, if this is true, my tension T is now equal to, this will cross over here to give me MA plus what? Mg. Okay, from this now, you can put in the parameters. My mass here is given as what? 0.2 times. My acceleration, look at from this formula, is V squared over R. So anywhere I see V, I'll put what? 5. So I have 5 squared all over. Anywhere I see R, I'll put what? 1.5 plus my mass is given as what? 0.2 times my G is given as what? 10. See, it's very, very easy to see. Okay, let me recap again. From my T minus mg equal to mass and acceleration, this can cross over here to give us plus. So we have the tension that we are looking for, tension on that string is given as what? Mass times acceleration. And what acceleration are we talking about here? The centripetal what? Acceleration. Plus mass times acceleration due to what? Gravity. Okay, we said that the formula for calculating centripetal force, centripetal acceleration rather, is given as V squared all over what? R. Where V is the steady speed with which the stone or an object is using to move in a circular path, and R is the radius of the what? Circle. Okay, we'll put in all the parameters here. Anywhere we see V, we'll put 5. Anywhere we see R, we'll put in 1.5. So let's expand this and see what the answer will be. Okay, we'll have 0.2 times 5 squared will give us 25, all upon what? 1.5 plus 0.2 times 10. So I will teach us how we can do this without using calculator. Okay, remember that 0.2 is centered as having 2 over 10 times 10 all over 1. 10 over 1 is centered as having 10. Okay, if that is true, we'll do the same thing here. I'm not going to use calculator to solve it. We'll do the same thing here so we can see. Okay, this centered as having 2 over 10 times 25 over 1 all over 1.5 centered as having 15 all over what? 10. Hope it's not confusing. You can use calculator to check that. 2 divided by 10 will give you 0.2. 15 divided by 10 will give you 1.5 plus 2 over 10 times 10 over 1. So we can now do simple mathematics here. 2 times 25 will give us what? To give us 50. 10 times 1 will give us what? 10 all over 15 over 10 plus 2 over 10 plus 10 all over 1. This is very simple to explain. Now watch, anytime you're solving maths, you have A over B all over X over Y. This sentence as having A over B times 1, Y will come up and X will come down. We're going to use that the same idea here. Okay, are you seeing it? 50 over 10 all over 15 over 10. Let's use that the same idea here and see what we are going to get. Okay, we have visualized this. Okay, from here, you see that we have 50 over 10 all over 15 over 10. So it can be written as 50 over 10 times 10 over 15 plus 2 over 10 times 10, 15 over 10. Okay, there. 50 over 10 over 15 over 10, the center is having 50 over 10 times, this 10 will come up, 10 over 15 will come down, just like this particular formula that I gave us here. Okay, plus 2 over 10 times 10 over 1. So we can simply finish our simplification. See that 10 will cancel out 10 here. 10 will cancel out 10 here. So we now have T is equal to 50 over 15 plus 2 over 1. Okay, let's see. You see, 5 here, 5 into 15 will give us what? 3. 5 into 50 will give us what? 10. So we have that the tension T will be equal to 10 over 3 plus 2 over 1. Okay, what's the LCM of 3 and 1 is 3. Okay. 3 into 3 will give us 1. 1 times 10 will give us 10 plus 3 into 1 into 3 will give us 3. 3 times 2 will give us what? 6. So T is equal to 16 over what? 6. 16 over 6, we can leave it in this form, or we'll leave it in a mixed fraction, or we can simplify it to the nearest what form. Okay, let's try to see whether we can simplify to the nearest form. 16 divided by 3 will give us what? I know I have 5, we can start it here. 16 divided by 3, so I have 5 here, 15, 1, I have to put the small point here, 3, 1, 0, recurring. So if I divide this, I have 15, 5.333, keep going. So I want to leave it in one decimal place. So my T is equal to 5.3 Newton. So the tension and the strength is what? 5.3 Newton. That's for question number 1. Okay, question number 2 says, a car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. So the car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. Like I said before now, we are trying to analyze the motion of a particle. What do we mean to analyze the motion of a particle? To analyze the motion of a particle, you need to get 4 things. They are 1, acceleration, 2, velocity, 3, displacement, and 4, time. If you can get these 4 things, you have analyzed the motion of a particle. Let me repeat again. To analyze the motion of a particle, you need to get 4 things. 1, acceleration, 2, velocity, 3, displacement, and 4, time. Let me write it here. To analyze the motion, any type of motion, we don't care, any type of motion whatsoever. To analyze the motion of a particle, we need to get these 4 parameters. 1, acceleration. 2, velocity. 3, displacement. And 4, time. If you have got these 4 things, you have analyzed the motion of a particle. So, the equation of motion, the equation that describe the behavior of a particle when it's in motion, will contain these 4 parameters. It will contain these 4 what? Parameters. So, in these 4 parameters, what they normally do in question is that they will give you 3 parameters and ask you to find 1 from the equation. Like in this case now, let's look at the parameters given and how we can get the required quantity that is missing. Okay. A car starts from rest. Now, please need to know the terminologies used here. If a car starts from rest, that means the initial speed is equal to 0. Don't forget, if a car starts from rest, or a body starts from rest, a particle starts from rest, anytime you hear from rest, starts from rest, know that the initial speed or initial velocity is equal to what? 0. Initial velocity is equal to what? 0. Initial velocity is equal to 0. Please, I will using speed and velocity interchangeably with the assumption that I know the direction of the speed. Okay, if that is true, we say that the car starts from rest. Because we hear starts from rest, the initial velocity will be equal to what? 0. So initial velocity, we normally represent initial velocity with u, but I will use v naught to represent the initial velocity. There's nothing wrong with that. initial velocity v naught is equal to 0 because it starts from what? Rest. Please, students should take notes. This is how you can solve questions involving the motion of a particle moving on a straight line with a uniform acceleration. Anytime you hear starts from rest, know that the initial velocity is equal to what? 0. Okay, let's proceed and see. And accelerates uniformly. That's what I told you. If the object does not accelerate uniformly, the equation will not work. If the object does not accelerate uniformly, the equation will not work. Even if the object accelerates uniformly and moves on a curved path, the equation will not also work. The equation only works when the object accelerates uniformly on a straight line. And this question now satisfies all these conditions. So a car starts from rest and accelerates uniformly. Because it starts from rest, that velocity is equal to 0, and it accelerates what? Uniformly over a time of 5.21 seconds. So the time taken for the object to move, let's say, I'm going to show us the visualization of all these articulations so you can see. So the time, we denote with t, small letter t. The time here taken for the object to complete this motion is 5.21 seconds. Okay, seconds. Okay. For a distance, now the displacement covered here. Remember, distance and displacement, they mean different things. But in this context, we use them interchangeably because of we know the direction of the distance. That is the assumption here. That's why they put the distance in this question. We know the direction of the what? Distance. Okay, the time here is given as 5.21 seconds. For a distance of, now look at the displacement. I said the distance is given as what? 110 what? Meters. So, like I said, I can use distance, I can use displacement interchangeably. They use distance here because they know the direction of the motion, they know the direction of the distance. Okay, so the displacement here, displacement is equal to 110 meters. Okay, to determine the acceleration. So we're looking for acceleration, we don't know the acceleration here. And what acceleration are we looking for? Do you remember? Uniform what? Acceleration. Not any type of acceleration, but uniform what? Acceleration. In fact, uniform acceleration here simply means constant acceleration. Constant what? Acceleration. Is x, displacement, equal to initial speed times time plus half acceleration times time squared. This formula is suitable for solving this problem. Now look at this formula. See that displacement is given as 110. Initial velocity is given as 0. Time is given as what? 5.21. You cannot calculate the what? Acceleration. So let's put in the parameters and see. Anywhere I see x, displacement, I'll put it as what? 110. So s is equal to 110 meters. U is equal to 0. T is equal to 5.21 seconds. So let's put in the parameters and see. 110 is equal to 0 times 5.21 plus 1 over 2 times a, bracket opens 5.21 all squared. So 110 is equal to, if you multiply this in here, we'll have 0 plus. So we're going to expand this. So we'll have all squared. So 0 plus this will still remain the parameter. Okay. So we'll have 1 over 2a, 5.21 all squared. So we're here. We want to get a. So basically what I'll do here is I'll cross multiply. So 2 will times this. 2 will times 110. 2 times 110 will give me 220 equal to a. Equal to a, bracket opens 5.21 all squared. Now I'm looking for a. I'll divide both sides by 5.21 squared. 5.21 all squared and 5.21 all squared. All squared. So this will cancel out this. So a is equal to 220 divided by 5.21 all squared. We can actually use calculator to point this thing through and get our answer. Continue. Okay, we are here. We now see that acceleration is 220 divided by, bracket opens, 5.21, bracket closes, all squared. So our work now is to expand this. 220 divided by our expansion. So let's expand it and see what the answer will be. So my A will be equal to 220 divided by the expansion is 27.1441. You can punch it to the calculator. So this divided by this now will give us 8.1049. 8.1049. I want to leave my answer in one decimal place. So the answer will be equal to 8.1 meter per second squared. Okay, that is the answer. Okay, the next question says, an object is thrown straight down from the top of a building at a speed of 200 meters per second. Full stop. It hits the ground with a speed of 40 meters per second. Full stop. Question number A says, how high is the building? B, how long was the object in the air? So, you see that in this question, the object did not start falling from rest. The object was given an initial speed, and the magnitude of that speed is 20 meters per second. So let us visualize the problem and see how it looks like and what is required of us. Solution. Like I said before, to do physics, you must visualize the problem. An object is thrown straight downward from a top of a building. So let's assume this is our building and this is the earth. This is the ground. This is the earth and this is the top of our building. This is the top of our building. And I have an object. Let's say the object is a stone. Okay, this is the visualization I want us to have. This is the stone, this is the height of the building, and this is the ground. So what happens in this case is that an object is thrown from the top of a building at a speed of it. So we'll now let go the object, now throw the object downwards. We gave it initial speed to throw it downwards. The object will not start falling from a height. Now look at the situation. This situation, letting go, is different from giving initial speed for it to fall down. So it was given initial speed for it to fall down. It wasn't let go. So because it was given initial speed to fall down, we gave it initial speed of 20 meters per second, and it hits the ground with a final speed of 40 meters per second. So let's see what that is all about. Okay? The initial speed V0 is equal to 20 meters per second. Now watch. Remember that speed in a given direction is velocity. So the speed here is in downward direction. Speed in downward direction. Because we're moving in downward direction, the speed will take up a negative value to indicate that it's moving towards the downward direction. So the initial speed here is what? Minus 20 meters per second. Okay? It hits the ground with a final speed. Okay, upon hitting the ground, it has a final speed V of minus what? 40 meters per second. Remember, this minus is coming in to tell us the direction of the what? Speed. Here, the initial speed given is falling downwards. That's why it has this minus sign. It's falling downwards. If you're going downwards, it's negative. If you're going upwards, is what? Positive. Okay. So the initial speed here is minus 20 meters per second. The final speed is what? Minus 40 meters per second. Okay, when it hits the ground, it has this final speed. So the asks us now, how high is the building? How high is the building? So which equation are we going to use to analyze this motion? Remember, in analyzing the motion of a particle or a body, we need to get four things: speed, acceleration, distance or displacement, and what? Time. So let's see. Now in this particular case, it's falling downwards. The acceleration due to gravity is given as what? 10 meters per second what? Squared. That is the value of acceleration due to gravity. And what we are looking for here now is what? The height of this building. We are looking for the height of this building. We don't know it. We are looking for the height of this building. We don't know it. We're looking for the height of this building, we don't know it. So which formula are we going to use and solve this problem? Remember our formula that says that V squared is equal to V naught squared plus 2GH. Okay, using the formula V squared minus V naught squared plus 2GH. Remember this V naught stands for the initial speed, V stands for the final speed. So my final speed here is given as what? Minus 40 all squared equal to V naught is given as minus 20 all squared plus 2 times 10 times what? H. V naught squared will give us 1600 equal to minus 20 squared will give us 400 plus 2 times this will give us 20. 20 times H will give us 20 H. So this will cross over here. We'll have 1600 minus what? 400 equal to 20 H. 1600 minus 400 will give us what? 1200. Okay? Equal to 20 H. So 20 H equal to 1200. I'm looking for H, the height of the building. Divide both sides by 20. Cancel. H is equal to 1200 divided by 20, which will give us 0 will cancel, which will give us 60 meters. Therefore, the height of the building is what? 60 meters. Okay, let's go to part B of this question. Part B says, how long was the object in the air? How long was the object in the air? Okay, I want to know how long it takes this stone to move from here to the ground. So the time it spent in the air is what we want to get. Just like you throw a stone from a building, you want to know the time it spent in air until it reaches the ground. So which formula are we going to use for that now? Now, if you watch here, you have gotten your final velocity, you have a final velocity, you have initial velocity, and you have your displacement, which is the height of the building. So since you have this, and this, you are looking for time. There is a particular formula that students neglect a lot. This formula connects displacement, initial velocity, and final velocity with time. This formula is a very important formula, and we are going to use it to calculate the time it takes, the time the object spends in the air. The formula says that X, solution B, the formula says X, which is displacement in this case, is equal to, bracket opens, initial speed plus final speed divided by 2 times what? Time. And this is the time the object spent in the what? In the air. So if this is true, the displacement here is given as what? Minus 60, not 60. Remember, the object is falling downward, so the displacement will be negative what? It will be negative value. To take up negative sign to show that it's falling what? Downwards. Remember that I told you, if you are falling downwards, you have a negative displacement. If you are going upwards, you have a positive what? Displacement. So the displacement here will be what? Downwards. So we now have that. This my head here that will stand for displacement will be now minus 60 equal to initial speed here is minus what? 20. Final speed is minus what? 40 divided by 2 times what? T. So if this is true, we can factor out minus outside here. So we'll have this is simple as having minus, bracket opens, 20 plus 40 divided by 2 times what? T. Minus will cancel our minus. So we'll now have 60 is equal to 20 plus 40 will give us what? It will give us 60 over 2 times what? T. 2 here, 1. 2 into 60 is what? 30. So 60 is equal to 30t. So 30t is equal to 60t. I'm looking for the time the object spent in the air. It will be 30 divided by 30. Divide both sides by 30. Cancel. T is equal to 60 over 30. 60 over 30 will give us 2. Therefore, the time the object spent in the air is 2 seconds. Okay, the next question says, a kangaroo is capable of jumping to a height of 2.62 meters. Full stop. Determine the takeoff speed of the kangaroo. Solution. Recall, for you to do physics very well, you must be able to visualize a given problem. So we have a kangaroo. This is the earth. So a kangaroo is capable of jumping. The kangaroo will jump up. Let's assume this is a kangaroo behaving like a particle now. This is a kangaroo now. Kangaroo can jump from this particular point on the ground, let's say point A to point B, which is of a height 2.62 meters. So kangaroo can jump from A to B 2.62 meters. Let's visualize this problem. We have that the kangaroo started from a point, let's say from 0, and it leaps upwards, takes off to a point, let's say B. When the object gets to this maximum height, B, the final velocity is equal to what? 0. So V is equal to 0. Remember, when an object gets to its maximum height, final velocity is equal to 0. Okay? Final velocity is equal to 0. Now, let's see, we are looking for the initial velocity, that's the initial speed with which the kangaroo will use to take itself up the ground. So, initial velocity V0 is equal to unknown. We are looking for it. Now, they give us acceleration. Acceleration is given as 10 meter per second squared. And they give us the displacement. Displacement here is a very interesting stuff. You confuse a lot with this particular thing. Displacement here means find where you stop minus where you started from. So displacement here is given as what? 6.62 meters. That's the displacement that we have. Okay. So we are going to use the formula that says V squared equal to V0 squared minus 2GH. That's the formula that we are going to use in this particular case. Okay? Anyway, I see we are put what? 0. So we're giving us V0 squared minus 2 times 10 times h, and my h here is my h is 2.6 So we can actually finish this particular up. 0 squared will give us 0 equal to V0 squared minus 2 times 10, 20 times 2.62 will give us okay, we have, using this formula, V squared minus V0 squared minus 2GH. Where V has stand for the final velocity and is equal to 0. V0 is what we are looking for, the speed which is used to take off from the ground, and minus 2GH. G is given acceleration due to gravity, is 10 meters per second squared. H is the height the kangaroo leap, and in this case it's just the displacement, but we'll replace it with the height. So we'll start putting the parameters. Anywhere I see if we have put 0, 0 squared will give me 0. V0 squared minus 2 times G is 10 times height is 2.62. So 2 times 10, 20. 20 times 6.6, 2.62 will give me 5.5.
Pick up.
Okay. 0 squared is equal to V0 squared minus 2 times 10 times 2.62, and 2 times 10 is 20. 20 times 2.62 will give me minus 52.4. Okay, I'm looking for V0 here. I can actually collect like terms, and this crossover I will have my V0 squared will be equal to 52.4. I'm looking for V0, I'll divide both sides. I'll take the square roots of both sides. I'm looking for V0, in this case, I'll take the square roots of both sides. So this will cancel like this. My V0 will be equal to plus or minus square root of what? 52.4. But because of this leaps upward, I will not work with negative value, because going upward is supposed to have a positive value. What I said is that going upwards, we have positive value. Coming downwards, we have negative value for my velocity. So I will remove this. I will neglect the negative value of my solution. and say that my V naught is equal to square root of what? 52.4. If you punch your calculator, square root of 52.4 will give you V naught equal to. Now, we say that my V naught is equal to plus or minus square root of 52.4, but because it's going upwards, I will drop this negative value and take my positive value. So initial speed will be equal to square root of 52.4. Square root of 52.4 will give us 7.23878. Now, I want this my answer to be in one decimal place. So the initial speed with which the kangaroo used to take off will be given as 7.2 meter per second. That is the answer.